Class 12th, subject physics. Let us see one of the practicals, that is sonometer. With the help of this sonometer, we have to prove law of length. So this is sonometer 1 experiment for the proof of law of length of the vibrating string. The experimental setup consists of the sonometer box. So this is the sonometer box provided with the rigid support at its one end, to which a thin uniform metallic wire will be connected. So as one end of that metallic wire is connected to this rigid support, it will be carried, that is, it will pass over this sonometer box, and then it will pass over this pulley at the other end of this sonometer box. Then at the other end of this sonometer wire, so at this other end, a hanger of mass 500 gram along with the slotted weights, each of mass equal to 500 gram, will be connected. So here we have connected 5 discs of 500 gram each, therefore 2500 gram, and the mass of this hanger itself is equal to 500 gram. So totally mass attached will be equal to mass of the hanger and the mass attached to the hanger, and that will be equal to 3000 gram. So like this 3000 gram mass attached at the other end of this wire will be kept constant throughout the experiment, so that the tension created in the string will remain constant throughout the experiment. And therefore now, in order to find out the vibrating length of the wire, there are two knife edges, movable knife edges, set on this sonometer box. These two edges will be moved to and fro so as to adjust the vibrating length of the string. The vibrating length of the string is the length of the string between these two knife edges. And then for the measurement of this length on both sides of this sonometer box, the scale is provided. Sometimes externally we can use the meter scale for the measurement of this length. Similarly, at the center of this vibrating length, a paper rider, that is very small piece of paper, is kept, and then when any tuning fork is set into vibrations and if its stem is touched to this table, at that time that paper rider may flutter or sometimes it will fall. Now when it is fluttering, at that time we can say that we have reached close to the correct vibrating length of that string. And if it is falling down, if it falls, then we can say that we have got the correct length, that is vibrating length of that string. Similarly, tuning forks will be provided to us. So these are some of the tuning forks. Now they will be first arranged in ascending or descending order of their frequency. Here they are arranged in the descending order as 512, 480, 420, 381, and at last there will be an unknown tuning fork whose frequency we will have to determine. Then paper riders will be very small in size. So these are the very light paper riders. Then in order to set the tuning fork into vibrations, this rubber pad is provided there. So with the help of that rubber pad, if we hammer one of the prongs of the tuning fork on it, then that tuning fork will be set into vibrations. Now after setting the tuning fork into vibrations with the help of this rubber pad, the stem of this tuning fork will be kept in contact with this sonometer box, so that the vibrations will enter into that sonometer box, and due to these vibrations that string will be set into vibration, that wire will be set into vibration, and therefore that paper rider may fall. When it falls, we can measure the length, that is vibrating length of the string between these two knife edges. And therefore, now let us see what is actually aim of this experiment. So to study the relation between the frequency and vibrating length of a given wire under constant tension using a sonometer. So we have to study the relation between the frequency and the vibrating length of the given wire. Similarly, we have to determine the unknown frequency of the given tuning fork. The apparatus needed are sonometer box, then tuning fork, then a rubber pad, hanger, slotted weights, meter scale, as well as the light paper writer. Now, if you consider this arrangement of it, then now we have to consider the formula for this. Now, what is the formula for this? So, for this law of length, the formula is, main formula is n is equal to 1 upon 2L square root of T by M, where n is the frequency of that tuning fork, or it will be equal to frequency of the vibrating string. Then L is the vibrating length of the string that we have to measure. Then T represents the tension in the string, which will be constant throughout the experiment. Then M is mass per unit length of the string, or it is also called as linear density of the string. Then second formula is n proportional to 1 by L, that is frequency is inversely proportional to vibrating length, or NL will be equal to constant. Then third formula is for the determination of unknown frequency, that is unknown frequency Nx will be equal to mean NL upon Lx. So with the help of this we can determine unknown frequency. Now let us see the observations. In the observation, we have to find out the tension in the wire, tension in the string, and that will be found as tension is nothing but weight, that is mass into gravity, and therefore mass of the hanger plus mass added to the hanger. Mass of the hanger plus mass added to the hanger will be multiplied by acceleration due to gravity g, and that will be equal to, now for this experiment we have added 2500 gram as the slotted weights, and therefore mass of the hanger 500 plus 2500, that is mass added to the hanger, into 980. All these quantities are in CGS units. That will be equal to 3000 into 980, that will be equal to, if we calculate that tension, it comes out to be 2.94 into 10⁶ dyne. And now let us see the observation table. So in this observation table, now if you consider the observation table, then the first column will be observation number 1, 2, 3, 4, 5 and so on. Second is the frequency of the tuning fork n hertz. Now according to the arrangement of the tuning forks, these frequencies we will have to write. For example, 512, 480, then 420, then 381, and at last there will be Nx, that is unknown tuning fork. So this is the frequency for unknown tuning fork. Then we will have to find the resonating length, that is vibrating, correct vibrating length, L centimeter. For each tuning fork we will have to find out twice the lengths. So first we will find the vibrating length, then it will be noted here. Then we will have to move these knife edges slightly to and fro, and then find out again the vibrating length for a second time. Then these two lengths will be added and their mean value will be calculated in the next column. Then find out the reciprocal of this mean L, that will be 1 by L centimeter inverse. And at last the product of this frequency of the tuning fork and the mean length L will be found in the last column, that is NL, that is equal to hertz centimeter. So for known frequencies the values of NL will be calculated, then find out mean NL for these values, and if that mean NL is divided by the Lx, that is the vibrating length for this unknown tuning fork, then we will get the frequency that is of the unknown tuning fork. And so in order to proceed, in order to take the readings, how to proceed, let us see. So for that purpose we have to adjust these knife edges by moving to and fro, and then set this tuning fork into vibrations. After setting the tuning fork into vibrations, the stem of the tuning fork will be kept in contact with this sonometer box, and therefore let us see, the paper rider will be always kept at the center of the wire, and then this tuning fork will be set into vibrations and its stem will be touched, so that this paper rider is now fluttering. Then now adjust again the length of the wire by moving the knife edge, so that again it is fluttering. Again adjust it, the length of the wire will be adjusted again, and then again it is fluttering with maximum amplitude. Then again adjust it. So it is again fluttering. Again we will adjust the vibrating length of the string, and now it is fluttering with maximum amplitude, or we have reached close to the vibrating length, and therefore now again we can strike it. Now it is fluttering again with maximum amplitude. Then it may fall after adjusting again slightly. So now it will fall. So like this, when the paper rider is fall, at that time measure the length of this wire between these two knife edges. So this length will be measured between the two knife edges. So it comes out to be, center is of the first knife edge is at 44, then for this is 58. So difference between these two, that is 58 minus this 44, so that will be equal to near about 14 centimeter. That will be the vibrating length of the string. Again for the same, we can move this slightly, then put that paper rider on this wire at the center, and again this tuning fork will be set into vibrations, and then the second reading for the same tuning fork will be taken. So this 14 centimeter will be written here, then second reading for the same tuning fork will be written here, then mean of these two will be calculated. So like this proceed for other tuning forks as they are arranged, and then complete this table. After completion of this table, now we will have to plot the graph. So for that graph, before that the calculations will be, all calculations will be made, that is 1/L for each reading will be found, except then NL will be found for all the tuning forks except that last NX. So we know 1/L for all the tuning forks including this unknown tuning fork, but NL we will know only for the known values of the frequencies of the tuning fork. And then we have to plot the graph of 1/L against N. So along x-axis frequency will be plotted, along y-axis 1/L will be plotted. For simplicity, here that scale is given, here that scale is as it is. So scale is on x-axis 1 centimeter equal to 50 hertz, on y-axis 1 centimeter equal to 0.01 centimeter inverse. So like this 1/L against N, that graph will be plotted. So all these points will be now plotted with their respective values of frequencies and this 1/L. Then we know that the value of 1/Lx from this observation table, for this unknown tuning fork, we know the value of 1 by Lx, that is reciprocal of the vibrating length for this unknown tuning fork. Now that value we will have to mark here on the y-axis. Then from this value go perpendicular up to this graph. A perpendicular will be drawn like this, and then here suppose that line is meeting here to this graph, then again come perpendicular to x-axis in this direction. So on the x-axis where that perpendicular is meeting, that will represent the value of that unknown frequency of the tuning fork. So from the graph as well as from the calculation, we can find out the value of the frequency of unknown tuning fork. So like this we can proceed. Then once we have got the values of the tuning fork, that is value of unknown, then from mean NL upon Lx we will get value of Nx, as well as from this graph along the x-axis where that perpendicular from the graph meets, that will also represent the frequency of this unknown tuning fork. Both these values will be nearly same, and therefore after completing this, the result of this will be written, that is the graph of 1 by L versus N is found to be a straight line. So in this case the graph of 1 by L against N is found to be a straight line. That means there will be direct proportion between 1 by L and N, and therefore this verifies that the law of length of the vibrating string, that is fundamental frequency of vibration of wire, is inversely proportional to its length when the tension in the wire and the mass per unit length of the wire both are kept constant. Now this can be also written as NL is equal to constant, NL is equal to constant. Then second of the result we can write the unknown frequency Nx of the tuning fork. Here we can write either calculated value or the value which we have obtained from the graph. So by both this method, either by calculation or by graph, we can find value of this Nx, that is unknown frequency of the tuning fork. And then at last, after writing the results, some of the precautions we will have to state, and these are: for measuring the resonating length L of the vibrating string, it will be measured directly with the help of the given meter scale between the two knife edges. So in this case the vibrating length must be always measured between the centers of these two knife edges. So with the help of meter scale we can measure it. Similarly, the paper rider should be light, and also it must be placed at the center of the length of the wire between the two knife edges. Similarly, place the paper rider at the middle of the wire between the two movable bridges always. For each reading we will have to adjust it. Similarly, strike the tuning fork gently on the rubber pad. Similarly, place the stem of the vibrating tuning fork. We have to place that stem of the vibrating tuning fork gently on the sonometer box. So don't hammer the stem of this tuning fork on this table. It must be just touch to this sonometer box. Similarly, while setting that tuning fork into vibration with the help of this rubber pad, gently it will be hammered. Don't hammer the tuning fork like this, that is simultaneously both the prongs of the tuning fork will not be hammered. So it will be hammered like this. Only one prong of the tuning fork will be hammered with the help of this rubber pad. So this will be the end of this